Hello everyone, welcome to this video. In this video, we shall solve a question from GATE 2009. This is a 2-mark question, and here they are asking if automorphism of G, right, aut G, this denote the group of all the automorphisms of a group G. So that means we have some mapping phi from the group G to the group G. So all such mappings of this kind which are contained within some set, we call that set as automorphism of the group G, and this is a group of automorphism. This itself is a group. We have proved this thing, correct? So now they are saying for this group, right, if we change this group G, then what would be the automorphism of each of these groups, and in fact whether the group of automorphisms of these groups that is a cyclic group or not. So we need to tell which one among these four is not a cyclic group. So remember, for any group to be a cyclic group, what do we require? We require that the group is written as generated by some element where this element is a member of G. This is the condition for a group to be cyclic group. Now if you remember that we have a result which tell us that automorphism of Zn, that is isomorphic to U of n. What is U of n? It is the set which consists of all the numbers which are less than n and are relatively prime to n, correct? And this forms a group under multiplication modulo n. So this group Un is isomorphic to the group of automorphisms of the group Z of n, right? So in the first case, you making use of this result, let's check whether automorphism of Z4 is cyclic or not. So that means in order to check automorphism of Z4 is cyclic or not, we will check U4 is cyclic or not. So we know in U4 the elements would be 1 and 3. Why? Because here the numbers which are less than 4 and are relatively prime to 4 are just 1 and 3. So you see, we can create whole of our group U4 using the number 3. So this is the number 3 generates whole of U4. How? Because if you take 3 raised to power 1, so that means we would have 3. So 3 mod 4 is just 3, which is a member of this group, correct? Next, if we take 3 raised to power 2, that is 9, and 9 mod 4 is 1. So this is the second member of this group. So that means taking just 2 powers, we obtain all the elements of this group. Hence 3 is a generator, and hence the group is generated by this 3. Hence we may write U of 4 is equal to the group which is generated by 3. And because U4 is cyclic, hence this group automorphism of Z4 is cyclic. Why? Because they are isomorphic to each other. So option A is rejected here because it is a cyclic group and we are looking for a group which is not cyclic, right? So you see the trick here. If not is very important. Sometimes we solve the question so fast that we ignore this not and mark the incorrect option, knowing the correct answer. Okay, so keep this thing in mind. For the B part, we need to look for automorphism of Z6. Automorphism of Z6 is isomorphic to U6 and U6 contain the element 1 and 5. Now, this group is also a cyclic group. Why? Because this is isomorphic to U6 and U6 could be written as generated by 5. How? When you take 5 raised to power 1, that would be 5, and 5 mod 6 is just 5, which is one member of the group, and 5 square is 25 and 25 mod 6 is 1. Why? Because when you divide 25 by 6, you would have 1 as the remainder. So 1 is also there. So we have all the members of this group by taking the powers of 5. Hence 5 is the generator of this group. Hence this is a cyclic group. For the third group, hence option B is also incorrect. For the third part, we need to solve for automorphism of Z8. For automorphism of Z8, we say this is isomorphic to U8 and U8 contain 4 elements 1, 3, 5 and 7. Why? Because the numbers which are relatively prime to 8 and are less than 8, they are 1, 3, 5 and 7. So you see the group which is generated by 1, if you take 1 power 1, 1 power 2, 1 power 3, 1 power 4 and so on, you will just get the number 1. So you would only have the singleton 1 as a member of the group which is generated by 1. So this is not equal to U8, correct? Similarly, for the group 3, for the group which is generated by 3, 3 raised to power 1, that is 3. 3 raised to power 2, that is 9. 9 mod 8 is 1. 3 raised to power 3, that is 27. 27 mod 8, that is 3, right? So 3 raised to power 4 is 81. 81 mod 8 is 1, and so on. So you see we only have 3, 1, 3, 1, 3, 1 with us. So these are the members here, and this is further not equal to U8. Similarly, for this group which is generated by 5, 5 raised to power 1 is 5 only. 5 raised to power 2, that is 25. 25 mod 8, that is 1. 5 raised to power 3 is 125, so it will again give you 5. So you see again we have the members 5 and 1, 5 and 1, 5 and 1 with us. And similarly, this is not equal to U8. Similarly, for the subgroup which is generated by 7 contains only the members 7 and 1, hence this is not equal to U8. So U8 is not equal to any group which is generated by A, where A is some member in U8. Hence this group U8 is not a cyclic group, and because automorphism of Z8 is isomorphic to U8, hence this is also not an cyclic group. Hence option C is the correct option. For the sake of completeness, let me also discuss about the option D. For the option D, is it a cyclic group or not a cyclic group? Let's have a look. So here in this case, you may see automorphism of Z8 is isomorphic to U10. And what is U10? It contains of 4 elements, 1, 3, 7 and 9. So here you see the subgroup which is generated by 3 contain the element 3 raised to power 1, 3 raised to power 2, 3 raised to power 3, 3 raised to power 4 and so on. So 3 raised to power is just 3. So 3 mod 10, how much is it? It is 3. Next, 3 square, it is 9, and 9 mod 10 is 9 only. Correct? Now 3 raised to power 3 is 27. 27 mod 10 is 7. And 3 raised to power 4, that is 81. 81 mod 10 is how much? It is 1. Hence you see, what is this? This is your group U10 only. So that means we are able to write U10 as the group which is generated by 3, and 3 is a member of this group, correct? So therefore this U10 is cyclic, and hence because automorphism of Z10 is isomorphic to U10, hence automorphism of Z10 is also cyclic. Hence we have our option C as the correct option. So I hope you understood the question well. Well, that is it for this video. Thank you for watching.